In this video, I will be talking about the notion of logical form, which will concern us when we study deductive logic. So, we want to determine which arguments are valid based merely on their form. So, much of this course, by which I mean Unit 2, will focus on sentential logic. Another word for this is propositional logic. This logic, sentential or propositional logic, allows us to represent the most basic formal features of arguments. So consider this argument here, which I've put again in standard form. Premise 1, Lisa is a Californian. Premise 2, if Lisa is a Californian, then Lisa is 10 feet tall. Conclusion, therefore, Lisa is 10 feet tall. This argument has a valid form. That's to say, any argument with the same form as this argument is valid. And as we've already seen, the form of this argument is called modus ponens. So any argument that has the form of modus ponens is a valid argument. And this form can be represented abstractly by replacing the normal English sentences with what we'll see are sentential variables. So here I'm using the fancy Greek letters phi and psi. And the reason why I'm using these is to represent that any argument where you replace one sentence for phi in premise 1 and 2, and then replace another sentence for psi in premise 2 in the conclusion, for any arguments you fit in for phi and psi, you will get a valid argument. So here, for instance, the sentence Lisa is a Californian is taking the value of the variable phi, and the sentence Lisa is 10 feet tall is the value of psi. Okay, so in addition to using fancy Greek letters, we can also use normal uppercase letters like P and Q, and I think I've done that in the readings and on the quizzes problem sets for now. But starting next week, we'll see the difference between using fancy Greek letters and capital letters like P and Q, but the difference for now will not concern us. But what's important is that what I'm trying to get at here by using these Greek letters is that no matter which particular sentences you slot in for the phis and the psis here, you will get an argument which is valid. And in that sense, when we use these variables, phi and psi, in this argument here, we represent the form that a whole bunch of different arguments can take. And as it turns out, any argument with this form is a valid argument. Okay, so again, this here represents a valid argument form, and the name for it, as we've already seen, is modus ponens. So again, the form of our argument 8 is as follows. As I've just explained, phi and psi stand for any declarative statement whatsoever. So phi and psi here are like variables in algebra class. So variables, for instance, like x and y. But x and y are usually stand for arbitrary numbers, whereas these variables here, they stand for statements. So no matter which statements you plug in for phi and psi in this form here, you will always get a valid argument. So a scheme like we have here represents the sentential form of an argument. Now, in general, the sentential form of an argument is obtained by replacing each basic or atomic sentence in the argument with a single letter. So if you look at what we've done here, We started with this particular argument, which included actual particular sentences. The sentences Lisa is a Californian and Lisa is 10 feet tall. And to obtain the form of this argument, we replace those with these letters, phi and psi. So you can obtain the sentential form of an argument by replacing each basic sentence in the argument with a single letter. And it's crucial here that it's the basic or atomic sentences that are being replaced by a single letter. So what does it mean for something to be a basic or atomic sentence? A basic or atomic sentence is a sentence that doesn't have any other sentence as a part. So consider the following, let's look at the following four sentences together. Sentence A. Andy is a philosopher and Andy is a Packers fan. Is this sentence atomic or not? This sentence is not atomic because this sentence contains two smaller sentences as parts. So what we'll see is that this sentence is a conjunction of two atomic sentences. So the word and conjoins two simple sentences. So the sentence Andy is a philosopher and the sentence Andy is a Packers fan, these are basic or atomic sentences. But this entire sentence here, A, puts together two atomic sentences by conjoining them. And so A is not a basic sentence. Let's look at B now. B, it is not the case that Amy is 6 feet tall. Is this an atomic sentence or not? The answer is that no, this is not an atomic sentence because in this sentence B, we have an atomic sentence, Amy is 6 feet tall, but we've added to that a negation. So we're negating the basic sentence, Amy is 6 feet tall. So the sentence B has the basic sentence, Amy is 6 feet tall, as a part. Now, what about sentence C, grass is green? This sentence is atomic. It contains no other sentences as its part. C is the most simple kind of sentence you can get. Now, what about D? Either it will rain today or it will be sunny. According to sentence D is not atomic because sentence D combines two basic sentences, i.e., it will rain today and it will be sunny. It connects them with the word or either or. And what we'll see is that this sentence is a disjunction of two basic sentences. So of these four sentences, A, B, and D are not basic. Rather, we can say they're complex or compound or molecular sentences. Any of this terminology will do. And only C is a basic sentence. So when we converted this argument here to its logical form, we only replace the basic sentences with letters. So premise 2, if Lisa is a Californian, then Lisa is 10 feet tall. Premise 2 itself is a sentence. It's a conditional sentence. However, just as conjunctions and disjunctions and negations, just as those are not atomic sentences, similarly, this conditional, if Lisa is Californian, then Lisa is 10 feet tall, the entire conditional is not a basic sentence. So therefore, when you create the logical form of argument 8, premise 2 is not a single letter. Rather, premise 2 is a conditional with two letters as a part of it because the conditional contains two atomic sentences. First, the sentence Lisa is Californian as its antecedent, and the sentence Lisa is 10 feet tall as a consequent. So when we create the form, we just replace those atomic sentences with letters. So I want to now tell you about two very strange but valid forms of argument. The first is as follows. If we have any premise whatsoever, and so any sentence phi as the premise, and if our conclusion is some other sentence, psi or not psi, the resulting argument will be valid. So no matter what our premises are, if we have a conclusion of the form psi or not psi, then the argument is a valid argument. And here's a second very weird but valid form. If our premise is of the following form, phi and not phi, then no matter what the conclusion is whatsoever, we'll have a valid argument. So why is this? When we turn to the semantics of our formal logic in a couple weeks, we'll be able to see more clearly why this is. But here is an informal explanation for now. The reason why argument form A is valid is because the sentence psi or not psi, no matter what the sentence psi is a logical truth. So for any sentence psi whatsoever, psi or not psi has to be true. That's to say that any sentence has to be either true or false. So if the conclusion is a logical truth, no matter what the premise is, no matter what the premise is, the argument is valid. And that's because since the conclusion is a logical truth, it's impossible for the conclusion to be false. So therefore, it's impossible for the premises to be true and the conclusion false. So let me put this again. Argument form A is valid because it's impossible for the premises to be true and the conclusion false, and that's because it's simply impossible for the conclusion to be false, and that's because the conclusion, psi or not psi, is a logical truth. Now here is why B is valid. B is valid because phi and not phi is a logical falsehood. That is to say, for any sentence phi whatsoever, claiming that phi and not phi is true is a logical falsehood. That is to say, it's impossible for it to be true that phi and not phi. So a sentence can't both be true and false at the same time. So, because it's impossible for the premises to be true, it's therefore impossible for the premises to be true and the conclusion be false. And that is why this argument is a valid argument. And again, we'll return to this in a couple of weeks when we turn to the semantics for our logic. And hopefully then we'll get a clearer or more precise reason for why these are in fact valid. So just to summarize our discussion of formal validity, and again, this is review from what we talked about at the end of last week, here is a few sentential forms, some of which are valid, and the other one is invalid. So perhaps the most important or central inference form is modus ponens. And this is a valid inference form. Now, if you recall from the last lecture, the way I presented it there was that the conditional was the first premise. But of course, the order of the premises in an argument does not matter for its validity. So here I have the conditional as the second premise. Okay, but whether you put the conditional as whichever order you put the premises does not matter for validity. What's important here is that if you have a conditional if phi then psi as one of the premises, and if you have another premise phi, then you can conclude that psi is true, the consequent of the conditional. And that's a valid argument form. for whichever particular sentences you put in for phi and psi. Now, an argument form which is invalid is affirming the consequent, where you have a conditional if phi then psi, but then you have you affirm the consequent of that conditional and try to infer the antecedent, and that is invalid, as the examples we saw earlier in this video. And finally, here's another example of a valid argument, which is called modus tollens. So if we have the same conditional if phi then psi, but if we deny the consequent, so we say if phi then psi, not psi, therefore not phi. So if we deny the consequent, we can infer the denial of the antecedent. So here are examples again of arguments in their sentential form. So each of these arguments here represents the form of an argument. And particular arguments of this form are ones in which the variables phi and psi are replaced with particular sentences. So these arguments demonstrate the sentential form of various arguments. Now, I'm going to quickly talk about some limits of our focus on sentential form. So the kind of logic, again, which we'll be studying in this first unit on deductive logic, is what's called propositional or sentence or sentential logic. So propositional logic is what we'll be studying. But there's many other kinds of logics. There's also first order predicate logic, second order predicate logic, and inductive logic. Now in unit 3, in a while, we'll be looking at something close to inductive logic, but we're not going to be looking at first order predicate logic or second order predicate logic. Now in general, for deductive logics, each logic comes with a syntax, a semantics, and a proof theory. Now these are fancy sounding words, and we'll not be talking about proof theory, but we will see in the next few weeks what it means to talk about the syntax and semantics of propositional or sentence logic. Okay, so these words will hopefully become a bit more familiar, and we'll see what we'll be studying the syntax and semantics of propositional logic. So the logic we'll study for the first part of this class, by which I mean Unit 2, our current unit, is propositional logic, and we'll be studying its syntax and its semantics. So again, that's what we're focusing on, propositional logic. So above, we saw a case where we had an argument which seemed valid but was not formally valid. And this was the argument from the premise that John is a bachelor to the conclusion that John is unmarried. So that was a case where we had a valid argument that was not captured by looking at formal validity. Okay, but putting aside cases like that, it's not even the case that all formally valid arguments have valid sentential forms. So I want you to consider the following. Premise 1, all humans are mortal. Premise 2, Socrates is a human. Conclusion, Socrates is mortal. So we've actually seen examples of arguments like this earlier in this lecture, as well as I think in the previous lecture. And hopefully it's clear by now how this argument is a valid argument. And furthermore, hopefully it's clear how this argument is valid in virtue of its form. So as we saw above, we could replace these words humans and mortals with the nonsense words bleep and bloop. So we could say all bleeps are bloop. Socrates is a bleep, therefore Socrates is a bloop. And that would be a valid argument, and that demonstrates that this argument is valid in virtue of the form, that it doesn't matter, the particular meanings of these words does not matter. However, let's say we wanted to capture this argument in its sentential form. And again, how that would work is that we replace the atomic sentences with sentence letters. But now, what we should see is that each of these premises and conclusion is itself an atomic sentence. None of these contain as their part sentences in the way that, for instance, this sentence here, if Lisa is a Californian, then Lisa is 10 feet tall. That's a complex sentence, which contains two atomic sentences as its parts, okay? But if we go all the way back to where we were, none of these sentences here that make up this argument have sentences as their parts, because these are, each premise and conclusion is an atomic sentence itself. So that means if we try to discover the sentential form of this argument 10, what we would end up saying is that premise 1 is a sentence phi, premise 2 is a different sentence psi, and the conclusion is some third sentence chi. However, hopefully it's clear that this argument form is not a valid argument form, okay? Because you could fit in any sentence whatsoever for these three variables, three different sentences, and there's going to be many cases in which you have completely unrelated sentences. So this, again, is not a valid inference form. And that's because when we're talking about the sentential form, we're not able to look at the internal structure or form of sentences. All we're able to look at is how sentences can be combined to form complex ones. So that is, in this course, we're going to nonetheless be sticking with simple propositional or sentence logic. So we will not see a formal way of representing this argument as formally valid, because that involves looking at more complex logics. And we're just going to be sticking with a way of understanding form, which we just use sentence letters and their connections. So what that means, because there's a general notion of validity and formal validity, and then there's the particular notion of sentential validity, which we'll be studying with our sentential logic. We have to distinguish from absolute and formal validity, okay? So we can call the general notion of validity absolute. So there's this very absolute notion of an argument being valid. But the notion we will develop using sentence logic is not so general. So which is to say that there will be many arguments which are valid in an absolute sense, which our specific theory of sentential validity will not represent as valid. So basically, what's sententially valid is what we can prove to be valid using the formal system that we'll be developing. But it's important to note that this notion of validity does not capture every single thing which is genuinely valid. Okay, it's just a part of what it means for something to be valid. But we'll be developing precise formal tools for understanding this aspect of validity. And the formal language of propositional logic, which we'll use, we're going to be calling PL for short, so propositional logic or PL. In the book, which we'll be doing the readings from, it's also abbreviated as TFL, or which stands for truth functional logic. So these are two abbreviations for the specific formal language we'll be using to capture validity. So again, what this argument 10 shows us is that even if an argument fails to be sententially valid, so even if its sentential form is not valid, it's still possible for it to be valid according to a richer logical theory. But we will develop a precise theory of sentential validity and a few techniques for deciding whether a sentential form is valid or not. And we'll be doing this with the formal language of PL. So just to anticipate, what we'll start doing next week when we introduce the syntax of this formal language PL. Here are the basic components of this formal language. So PL is a formal language, and so it comes with its own special symbols. We will be using uppercase letters to stand for atomic or simple sentences. So particular simple sentences in our language will use uppercase letters A, B, C, D, etc. And we'll also see that we can provide subscripts to these letters to give us even more. So we can also use symbols S1, S2, S3 to stand for particular atomic sentences. And in addition to letters that stand for particular atomic sentences, we will have special symbols that are called connectives, or they're also called operators. And we'll be using these special symbols, these connectives, to put these atomic sentences together into conditionals or conjunctions or disjunctions or negation. And then finally, we'll have parentheses to group sentences together. So that is just a preview of the kind of way in which we'll be developing a formal language for capturing sentential validity. And just to conclude, I want to remind you that this notion of sentential validity is only one aspect of the general notion of what that we might call absolute validity.